Okay, thank you very much. So, so first, thanks for coming here, for waking up so early in the morning. I will keep going with Vladimir presentation, talking about an application of this miniature instrument that MassTech has developed. I didn't know it was coming from Mars, so we will bring the instrument down from Mars. It's a Martian instrument, isn't it? So I think it should have been green, not white. So is my sushi fresh? I didn't want to have mass spec in the title, so I just removed everything from mass spectrometry. So we will talk about Scombroid fish poisoning. It is a disease that comes from ingesting histamine. Scombroids are mainly tuna fish. All the different tuna fish, as you can see, they belong to scombroids. And these animals are prone to form histamine during the preservation, if they're not preserved in the correct way. They're not only tuna fish, but there are several other fishes, and we will see. So the problem, the scombrotoxin, the so-called scombrotoxin is histamine. So we all know very well what histamine is. It's a biogenic amines, and in this case derives from the decarboxylation of histidine. There's an enzyme that is present in bacteria, in anaerobic bacteria. They use B6 vitamin as a cofactor, and then they will decarboxylate histidine to histamine. And that happens when the histidine that is exposed to the outside parts of the animals, when the animal is left, is not preserved in the correct way, or when it's old. It's a major cause of foodborne illnesses, and the problem is that it's stable, heat stable. So if you cook the fish, you will still remain. It's strongly regulated, of course, worldwide, and it is regulated both in EU and in US with 100 ppm. In Europe, acceptable. In the US, it's 35. They just reduced from 50 to 35 2 years ago. And the maximum levels is 200 ppm. And this is highly controlled. All the worldwide fish industry, they do control and do make continuous monitoring of the fish products to stay below 200 ppm. Okay, so it's present in Scombroid mainly, these are tuna, but also in sardines, anchovies, in dolphins, dolphin fish, in bluefish, and in soy. So it's present in almost all fish that we eat. So as this is the instrument I've been using, it's the new version of the MT830 that Vladimir explained to you. Again, I didn't know it was coming from Mars, and I'm very happy about this. So we will bring it to the Earth for general application, everyday applications. Okay. So the sample prep is very, very simple. The instrument is very nice because it has a heated inlet, so you can just put the sample in the inlet with or without any sample preparation. So what we were doing, we were just wetting 1 milligrams of fish samples and add some water, homogenize it. We use some internal standard to do quantitative analysis since there is no chromatography in this sample, in this instrument. We did a quick centrifugation in it cold and filter it. Personally, I would have just used fish as it is, but this is a work of a PhD student candidate, and so he has to be precise, and so he went through all the steps that we formally accept as professors. So we just then, we deposit 2 microliters on the heated inlet, and we run the sample. Note that the reference method that is described in the EU official methods is an HPLC MS method, so it's time consuming and complex. So this is the sample introduction we were talking about. So in front of the instrument, this is the APCI source. There is a small sample holder. Here there are some glass holders, as you can see. You put one of these glass up here, you load the sample, or you put the sample, you put a piece of fish, a leaf, or whatever you want, and then you close the source. And when you close, it will turn on and it will run and acquire the samples. So sample introduction is extremely, extremely versatile. This is a calibration line we had from histamine, loading nanograms on the instrument. You can see that we can detect 1 nanogram, but the linear part is about 20 nanograms on top. If you think that we use 100 milligram of fish samples, this will be 100 ppm as a LOQ in fish samples. So what we did, we bought some sample in a grocery store and we divided in 2 portions. One portion was without histamine, as it is, and the other was added with 200 ppm of histamine, that I remind you that is the limit. These are the results. Here is the total ion current profile. So I load the sample, I close the door, and then I start to acquire. And then I warm up. There's an infrared heater that warms up the sample, and you can see the desorption. So without histamine added, that particular sample was clean, so there's no ion there. But then this is the sample with 200 ppm. You can clearly see the 112 ion that is appearing. And you can, the software allows you to reconstruct a chromatogram. So if you just select the ion, you can see that the 112 ion is coming out, is being well thermally desorbed. And so what I want to tell you is that this is a nice application, and we hope to move this application to the industry for screening of the sample. But when we think of a portable instrument, this has been done in the lab, but there are so many applications, and they need a complete different cultural approach for the analysis. So I'm a biologist, I'm a toxicologist, I'm not a chemist. And so I always have discussions with chemists about the quality of the analysis and the need of the quality of analysis. So if you have a transportable instrument, if you run toxic compounds, hazardous compound, you can just put it under the hood. So we were running chemotherapeutic drugs. These are carcinogenic compounds, so we don't want to thermally desorb in the air toxic compounds. So you can just take the instrument and put it in the hood, and it will just use a very little space and can sit in the hood within all other chemicals. This also, if you synthesize toxic compounds, you have intermediates that are toxic as well. And so this is another application we did in the hood. And we tried both APCI, we tried the electrospray source, and we tried thermal desorption. So the instrument is very flexible because it's an atmospheric pressure inlet, so it will ionize anything that enters inside the capillary the sampling capillary. So you can use any kind of ionization approaches you need for your problem. You can bring it everywhere. This is transportable. So we were at the aquarium in Genova. Below the aquarium, there are the coral. They are reproducing the corals, and the corals emit DMSO. And so we were monitoring DMSO emissions from corals in air. You can bring it around. We brought it at the International MassTech Conference, at the informal MassTech Conference this year. And we turned on the instrument and everybody was coming with their samples. And so we even had some students that came with CBD samples, and we could find it very easily. Of course, if you have a CBD sample, you have a huge peak of CBD. And coffee, and everybody was coming. So what I do also, I use it for teaching lab MS courses. These are both undergraduate courses here. You see, this is the old version. Undergraduate courses, or you can have advanced MS courses, because the instrument runs MS or MSMS with different ionization. So you can discuss all the application of MS with students. And also, you can connect it to other commercial instruments in HPLC that is on display on the booth here, down here somewhere, at 223, I guess, I'm not sure. Oh, this is the secret source that connects to the instrument. But also you can test all your ideas. You can use your fantasy. So what I did, I used an ozone generator as a barrier discharge ionization to ionize hydrocarbons in air. So this is an hydrogen generator. You see, you just remove the source and any kind of ion will be ionized. So this is an ozone generator. I lost this. That will produce ions out of the gas. This is a paper spray approach. We did it for matcha tea analysis. I used a laser marker to test as a MALDI ion source. And I also did the post-desorption UV ionization with a laser marker. Then I added an UV lamp to post-desorb, to ionize desorb molecules, neutrons. So you can test your all ideas, your fantasy, very, very quickly. The near future, now it's coming from Mars. Can we bring it at home? An ion trap, the problem is that at home we don't have cooling gas, but as Vladimir told you, they came out with the idea of using hydrostick. This is a metal hydride container that we release hydrogen, and so there's no hydrogen, no cooling gas needed, so you can use it really everywhere, even at home. And you can just fill it with a Barbie-size hydrogen generator, hydrolysis system. So I hope you got your transportable instrument up here. He's walking. So he came to my home and I brought it at home finally. So this is my house and my kitchen, and this is the instrument that is on and up and working. And the idea is, can I run samples at home? Can I just test my sushi? Is my sushi good? So I could not test my sushi because of the procedure the student prepares is too bulky. I don't have a centrifuge in my kitchen. So I've been testing all the spices I had at home. But beside the noise, it's something you can do it at home. And I was flying here with Air France, and I was looking at A Complete Unknown. I'm a Bob Dylan fan. And when I was looking at this movie, I was thinking that the times are really changing. I mentioned to you I'm a biologist, I'm not a chemist. And so I have a completely different approach to chemical analysis. And this is something that can help you to develop your crazy ideas, as I show you, using the ozone generator to produce ions from air. And since we're here, the times are changing and you better start swimming or you'll sink like a stone. So thank you very much. So these are all the collaborators. I'm working at the University of Milano Bicocca. Tommaso is the PhD candidate. Alice Passoni, she's here. She helped us very much with all these practical SRA instruments in Italy, and MassTech here. Special thanks to Vladimir for his patience with every time I break, I use the instrument, I break, I call him, and he fixes on the phone for me. And so thank you, Vladimir, for your patience. And thank you all.